So my first AI system, I actually built in 1983. I've actually been working in AI at this point for 40 years. And believe it or not, I think we've still got another 40 years to go. People always think we've finished, but we haven't.
Welcome to Longevity by Design, a podcast designed to give individuals access to the leading scientific information in the field of longevity. The ability to add years to your life and life to your years needs no opinion. Join us as we ask science to take the wheel. In each episode, Dr. Gil Blander joins a co-host and an industry expert in the field of longevity, shining a light and getting the answers to the key question: how can we live a longer, healthier life?
Hello, I'm Dr. Gil Blander. Welcome to Longevity by Design, how to live longer, healthier life. We are produced by InstaTracker, your science-based guide to optimize your body from the inside out. Our guest today is Professor Ronjon Nag, an inventor, educator, and serial entrepreneur working at the intersection of artificial intelligence, genetics, and longevity science. Dr. Nag is an adjunct professor in genetics at the Stanford School of Medicine and became a Stanford Distinguished Career Institute Fellow in 2016. He teaches courses spanning AI, genetic, ethics, longevity science, and venture capital, and has played a formative role in translation emerging technology into real-world impact. He is the president of the R42 Group, a venture capital firm that invests in and build AI and longevity-focused companies. A pioneer of smartphone and app store ecosystem, his companies have been acquired by Apple, BlackBerry, and Motorola. Dr. Nag has received numerous honors, including the 1 million Verizon Powerful Answer Award, and was inducted into the Silicon Valley Engineering Hall of Fame. He holds a PhD from the University of Cambridge, an MS from MIT, and a BSc from the University of Birmingham in the UK. Dr. Nag, welcome to Longevity by Design.
Thank you for having me. What questions are you going to ask me?
Yeah. Before we dive into the question, for our audience, if you are enjoying Longevity by Design, please like and follow the podcast on Apple Podcasts, Spotify, and YouTube, so you don't miss any future episode. So you asked me about the question. So I would like to ask, with your background, and specifically, you have been a pioneer in smartphone and app store, and now you are deeply involved in AI, biology, and longevity. Can you walk us through your journey and how these worlds came together?
Great, excellent question, because I'm actually an engineer by training, but I'm not a professor in the engineering department. I'm a professor in the medical school. So my first AI system, I actually built in 1983. I've actually been working in AI at this point for 40 years. And believe it or not, I think we've still got another 40 years to go. People always think we've finished, but we haven't. I did electrical engineering and then did AI at Cambridge in the 80s, and using neural networks, which computer scientists actually didn't believe would work. They never thought that technique would work. It's what modern AI is based on, a technique known as neural networks, where we actually have a mathematical model of the neuron and we connect them together. Continued to do that at MIT, and then at Stanford. Again at Stanford, this is 35 years ago. This is not engineering again. It was in psychology. So the mathematical psychologists at Stanford, AI is really invented, not in computer science, but in the psychology department. I'd written a letter to the most famous professor in AI at the time, Professor David Rummelhart, and said, "Can I spend a year in your lab? We've got this fancy scholarship to come to the States." And I said, "Sure, come on over." And I was a bit nervous because I was expecting an invite from the computer science department, but I actually got it from the psychology department. I didn't know anything about psychology, but it was okay. He'd collected physicists, engineers, mathematicians, philosophers, even linguists, to figure out the mathematics of the brain, and could that be used? And that could be used. Ended up being used for the first boom of AI in the early 90s, the first neural network boom. There were other booms before that. The term artificial intelligence was actually coined in 1956, The term machine learning was coined in 1958. If you actually go back, often people regard the father of AI as being Alan Turing. That goes all the way back to 1935. And so after all that, MIT, Cambridge, Stanford, no one would give me a job. So I had to start companies. That's what you do in Silicon Valley. There's the opportunities. You have a big role model effect. Lots of people start companies. So, well, if he can do it, maybe I can do it too. And started the first one, which is doing speech and handwriting recognition. And that got bought by Motorola. At our peak, we were 3 people. But involved in Motorola making the first, really the first smartphones. And these are the first smartphones were really in the mid-90s, late 90s, which had voice dialing, speech recognitions, browsers, handwriting recognition. Texting was invented in the late 80s, and people needed to figure out how to get the text inside the boxes. The second company was doing mobile app stores, so sort of crowdsourcing intelligence. And the third company was back to speech recognition. I was more the advisor, investor then, and how to get dialogue systems work. This is before GPT. And one of the problems is, how do you maintain state? You can say, I want to go to a restaurant. I want to go to a restaurant in London. I want to go to a restaurant with Wi-Fi. And it starts giving you mobile routers at the last question because it thinks you're on a different topic. So those are the sort of early versions of language modeling. So I did all that. And then, as I said, Stanford has a program where you can come back to university. And if we're all going to live till 100, universities are great at teaching 18-year-olds. They're great at teaching 22-year-olds for masters and 25-year-olds for PhDs. But if you're going to live to the 100, maybe you need to get re-educated in your 50s and 60s and 70s. So I did that. I wasn't quite sure what to expect. And this is where you just take courses with the 20-year-olds. The regular course, it's not an executive program. You just take the regular courses and work with them on the student project. So I took all the biology courses, the medical school courses, and I took so many that finally made me professor, but in medicine, not in engineering. And I teach, and then the tables are turned. I'm teaching longevity science. There was no longevity science program. And then I'm teaching business of healthcare. Again, the medical students want to start businesses. And then I'm teaching AI for healthcare. Again, the biologists and the medical students want to learn how to use AI for healthcare problems and projects, because hitherto medicine's had a history of being kind of a trial and error process, and we've had a genius somewhere who's got an intuition and comes up with an idea, and they try the idea and it works, and you have lots of other geniuses as well. They try an idea and they don't work, and there's no rhyme or reason really why one works or another works from an a priori point of view. It's just maybe a stronger intuition. So these days we've got something called data science. We've got something called AI, maybe put a more scientific imprimatur onto the problem, and also try and actually more bridge the causation correlation chasm. When you see many academic papers, or you will hear something on the radio, hear on something in the see something on television, they'll say, stop eating margarine, eat butter. Then they say, stop eating butter, it's too much fat, eat olive oil. To try vitamin D. People don't have enough vitamin D. Oh no, you're having too much vitamin D now. And things are being recalled. People change all the time, and one of the reasons is that we don't have a causation framework that's easy to understand, and then it takes a lot of effort to actually make sure that it is you see a causal relationship. So that's how I sort of got switched into medicine. My little half joke, and it probably is only a half joke, is the field's been using trial and error for a long time, and now you can use some quantified elements. The other dynamic is medicine's risky, biology's risky. Why is it risky? Well, it's risky. Why is it expensive? Medicine is expensive. Why is it expensive? It's because it's risky. The other layer I put on top is finance. So in finance, we actually have ways to deal with risk. It's called portfolio theory, and there are other ways to measure risk. And there's work out of MIT under Professor Andrew Lowe, who was my advisor 30 years ago. He was my advisor 30 years ago, 35 years ago, actually. His view is he wants to fix medicine, but not with science, but with finance, right? So the reason medicine doesn't get done and these new ideas don't get done is because they're expensive, they're risky. And the idea is, can you actually do projects? This is what I do in my first persona is I'm a teacher. I taught 2,000 students last year at Stanford University. But the second persona, I'm a venture capitalist. So I put money where my mouth is, put money to work, usually in pre-seed, early stage companies in the realms of AI and longevity science. And so how can you actually reduce risk? Well, you can reduce risk by looking at things that are counter-correlated. So if you go to the bank or you go to the stockbroker, they'll make a fund for you that reduces your risk. They'll put some stocks in maybe Walmart, and another one, others in Exxon Oil, and another one in Nvidia stock, and all these are different industries. And the idea is when one is up, there's another one's down, and another one is up. They're counter-correlated. So you're trying to find counter-correlated industries. So you can do that in medicine as a fund as well. So you can actually find ideas that are counter-correlated to reduce your risk. So you can actually do more. If you reduce your risk, you can actually do more projects. So for example, you might be investing in an obesity drug. We actually have one, what's called olfactive biosolutions. It does GLP-1, but as a food, not as a prescription. We can talk about it later if you like. But then you might want to do a Achilles tendonitis drug, something that helps tendonitis, because usually runners are not usually fat, right? They don't have the problem of overweight. And so you might want to put those together, automatically reduce the risk of both of them. So neuro drugs, solutions are notoriously risky. There's been no real answer to Alzheimer's ever, except for recently, and only half kind of work. And so if you're investing in a preclinical drug, you have a 5% chance of getting to the end. In neuro, you have a 0% chance of getting to the end. So why should
based on the history?
Yeah, based on the history. No, yes.
Yeah.
That's a good point, Gil. Yes, you have to, based on the history. So you have to put another layer of thinking on top. So one is, okay, what's different now? What's changed now? Is this a new technology, a new idea? Why do we think this new idea will work? And let's say if it's preclinical, the stats are still bad. But does it mean shouldn't invest? No, it doesn't. We've got several neuro companies. But we balance it with companies that we've invested in other areas. So that's my second persona, as I'm an investor. Third persona, I'm an inventor still. So I've got really 3 companies I'm working on. The biggest idea is Agemica, which is working on a vaccine. A vaccine for what, you may ask? It's a vaccine for aging. We'll talk about that later if you like. The second one is Ixana, which is coming up with a solution to dry age-related macular degeneration. Maybe older people might have it, or older people might have relatives or friends who have it. There's 2 forms, wet AMD and dry AMD, age-related macular degeneration. Wet AMD, there is a solution. It's an injection in the eye once a month. They're not particularly comfortable for the doctor or the patient. But for the dry version, there's no cure. There's actually no cure. And that's actually the most common version. And so we have a solution of gene therapy for that. And the third venture is superbio.ai, which is an AI life scientist where you can vibe code solutions to problems of AI, problems of life sciences. When I say vibe code, those are, maybe people have not heard of that term before. That's where you write in plain English what you want, and the AI will actually write the code for you. And that's probably one of the biggest disruptive forces going on right now. People take pot shots at it, saying, well, it doesn't make product level code, et cetera, et cetera. But it makes amazingly first drafts, and the tools are getting better and better and better. And you can sort of do a straight line projection that eventually you have an idea and you just tell the machine to build it for you. So much so, there have been many articles saying, there's one recently that Stanford computer science graduates are not getting job offers. That's like a tier 1 university with a tier 1 subject, one of the best subjects in the last 4 decades. You tell young people, go and do a computer science degree and you'll be fine. It's actually we're not quite sure about that anymore. So there's lots of things I've talked about, Gil. You can sort of take your pick and which you like.
No, first, it's a great introduction, and I've seen the article about Stanford. It was on Friday, so it was really recently, this article.
Yes.
And it was amazing because they're saying that on every 10 developer in the past, now you need only 2, and the 2 should be more senior. So the question is how junior developer will become senior. So it's raised a lot of questions, but I'm not sure that we would like to discuss it today. So I'm really excited about the introduction that you provided, and I have a lot of follow-up questions. So maybe we'll start with the next one. You often describe health and aging as a complex system problem. How does system thinking change how we approach longevity?
System thinking, I've been working and thinking about system thinking for 30 years, ever since I was at MIT, where they thought about system. There's a field known as system dynamics. Again, you can do it mathematically and look at, as things go up, other things go down, and things affect this and other things affect that. You can draw diagrams, loops of things that have negative impacts on loops, and then things that have positive impacts on loops. So if you start behaving yourself, start doing exercise, start doing diet, then you get healthier. And but then, of course, that takes time. It takes time to do exercise. It takes time to do, if you want to do an hour a day, that takes time away from doing work, away from your job, away from your family. So you have negative impacts. So you may get less income as a result. You may have familial stress because you're not spending enough time. It's only 24 hours a day, and you've decided to spend that on your health. And your family probably like you to, but they'd also like you to show up for dinner and not do your workout. I'm always getting chastised for doing my workout just before dinner, and I'm late for dinner as a result, right? And so that's not good for family relations. But also, I think so. That's sort of a systems level. The other dynamic is causation and correlation. So let's take the example of smoking. Fairly obvious example. People, I don't think it's disputed now, of course, that smoking is bad for you. But in 1960, that was not the case. It was actually debated, believe it or not. It was actually debated that smoking, and I'm seeing a little bit of a dynamic like that in wine drinking recently, that in 1960, everyone smoked. Today, we even people who are health conscious and longevity oriented still drink wine. They still drink the odd glass of wine, drink alcohol. And the usual recommendation is no more than one a day or something. I do more like one a month. But even that, I'm sort of thinking of terminating. That the Surgeon General of the US went on record, probably not very popular, but said any amount of alcohol is bad for you. And then amongst young people, it's fallen off a cliff, 40% reduction in alcohol drinking. And you can see now in the supermarket that beer companies are coming up with non-alcoholic beer. So I wouldn't be surprised 15 years from now that alcohol has the same view as smoking did in 1960. Now, how do you prove it, though? How do you prove alcohol's bad for you? How do you prove smoking was bad for you? Now it seems so obvious. But there's a chap called Austin Bradford Hill in London in 1960. He didn't have any computers. DNA was only just discovered a few years before. He was knighted. So Sir Austin Bradford Hill. And he said, well, look, it's obvious that people who smoke get cancer. Look at people in London; they smoke and they get cancer. And the lobby said, no, that's just because London's polluted. It's not because they're smoking. Well, he said, Paris, people who smoke in Paris, they get cancer too. Well, Paris is polluted as well. I said, okay, all right. So he came up with this 10-point checklist. So one idea was, well, okay, you get the cancer after you smoke. That's a good checkpoint, right? It's a checkpoint, cancer after you've smoked, not before. And then if you smoke more, you seem to get more cancer. So that's another good checkpoint. So he had like a 9-point checklist. So, is there any other reason why you could get cancer? I mean, are you a coal miner? Well, if you're a coal miner and you get cancer, maybe there's other reasons, right? But if you're not, if you're a desk worker, then maybe. So you go through this sort of 9-point checklist and think about the system. Typically, you will see, particularly in aging science, there's lots of popular press articles that pop up. And you really have to not check your brain in the door. That you have to really think in a systems point of view and a causation point of view. So, what was the one that came up a couple of years ago? People who have dogs live longer. Okay, so
yeah, but they are walking outside because of the dogs, so they are accumulating more steps, and that's why they might live longer.
That's one reason. It's the walking, not the dog bit.
Yeah. But it forces you to walk. Yeah.
Yes, that's the other bit. Also, you have to be healthy enough to have a dog,
correct,
right? So because you have to go on the walk. So if you're not healthy enough to go on walks, then you're probably not going to get a dog, right? So you have to sort of think. Not check your brain in the door. Almost every week there's an article that says this or that, and I know you do Inside Tracker. You're trying to measure people. You actually kind of need data, and that's probably the other revolution in the last few years. Is the wearables that pop up. And I used to be quite critical of these wearables actually, because I'd buy them and I'd put them in a drawer after a couple of months because I'd lost the battery. I'd lost the charger, and so I couldn't charge it. And then when I found the charger, I'd lost the battery, and so I couldn't. It's a slow cycle, and so and then I just put it in a drawer after 3 months. But now I'm an addict to it. I have to have a wearable. It nudges you. It's not so much data itself; it's the reminder for you to be on good behavior.
Yeah. And
it's almost a leaderboard, a competition. Every morning I look at my resting heart rate. And if it's a little bit higher than usual, and it happens time and time again, it's been an indicator for a potential illness. And so if it's an indicator, if it's a little bit higher than usual, so maybe I should take a zinc tablet. Maybe I should take it easy, be a bit more relaxed today to be able to fight another day, so to speak. And so and the human, even if you're not trained in health or anything, you start noticing these numbers that sort of indicate whether you're healthy or not healthy, and whether you're behaving yourself or not behaving yourself. I'm on a project at Stanford where they measure everything about me all the time. They take blood every 6 weeks. They take poo every 6 weeks. They don't tell you about the poo until after you've signed the consent form, but it's throat swabs, nose swabs, been sequenced 3 times, and it's been going on for about 7 years now. And what's interesting, they give you the data back, right? So you can see your LDL, HDL, A1C, not once a year, which is what most people. Certainly in the US, most people, if they have access, they have a yearly physical. The insurance company usually lets them have a yearly physical. In other countries, I'm here in Britain at this very second, they don't seem to have that. So you wouldn't even get that.
Yeah.
But if you get it every 6 weeks, I didn't do any workouts the last few weeks, and you find your metrics getting worse. Or if you ate chocolate cake and Ben and Jerry's ice cream, then you find your metrics impacting your LDL, HDL values start getting worse. And conversely, if you behave yourself, they can start, within even like 3 weeks, they start getting better. I think I went on a vegan, no sugar diet for 3 weeks between Thanksgiving and Christmas, and I had the best metrics when I was on that diet. I probably can't do it forever, but it sort of, again, it encourages you. So is it the sugar or is it the vegan? I think probably it's more the sugar. And encourages you to say, well, sugar's poisonous. Sugar's poison. Maybe it'll be a Surgeon General recommendation sometime saying it.
Yeah, and that's a good point. And I think that we like to say at InstaTracker, blood don't lie, meaning if you have a data from the blood data and you see that the marker went up or down or changed, then basically it doesn't lie. It's basically reflect what happened in your body. And that's the feedback loop that you really like, because it's giving you the feedback. It's unbiased. It's not like you cannot come to your wife and say, hey, it's your fault. It's that's the reality. And for a lot of people, that allow them to receive the feedback loop. And based on that, they will know, oh, in the example of the alcohol, you might see the liver enzyme going up. And then hey, I drink alcohol, my ALT, GGT, and so on are going up. So I know that something is bad. Maybe I will drink less alcohol. So I completely agree with you. The addition of the information allow us to get a much more educated and also start using it as a feedback loop for us to become a better machine. And you are a person of engineering and all of that. So you are thinking in the machine learning way. So my follow-up question for that is, as we discussed in your background, you have an amazing background about AI, and you spoke about AI when nobody else knew about AI.
As a Longevity by Design podcast listener, you understand the value of improving your health for today and for all the years ahead. And if you want to live your healthiest, longest life possible, you need to understand what's going on inside. At InsideTracker, we take a personalized approach to health span optimization that eliminates guesswork from your wellness plan. InsideTracker analyzes blood biomarker and DNA data, along with physiomarker data from fitness trackers like Oura Ring, to deliver personalized food, supplement, lifestyle, and exercise recommendations that allow you to take control and improve your health span. And for a limited time, Longevity by Design listeners can get 20% off at the InsideTracker store. So if you're ready to receive a personal health analysis and data-driven wellness plan to optimize your body for the long haul, then it's time to start inside. Visit insidetracker.com/podcast to get started today. That's insidetracker.com/podcast to get started today.
So what is in your opinion, will be the effect of AI on biology and aging, research, and also a lifespan in the future?
Yes. It's interesting. When I started in my AI career 40 years ago, I thought I was late to the field. That's right. Because the term was coined in 1956. But it's so it'll be it will be a huge impact in every form of life. AI is going to be like PowerPoint within 18 months from now. It's a bit like you probably remember, when spreadsheets came about, you had to be trained in it per se to use it. And then now, a fresh graduate, you go to it, you're not expected to be trained in Excel. You're just supposed to know. And I think AI is going to be like that in the next couple of years. Every company, in the early 2000s, companies were saying, I'm an internet company. They don't say that anymore, that I'm an internet company. And you'll find that if you're an AI company, people are saying that now. And they won't say it in a couple of years' time. They won't be saying that. Of course you use it. It's like, are you using a computer? Yeah, I'm using a computer. But what's the impact going to be? I mean, what the big difference is that the big difference is you've got you're doing language modeling. The way it is important to know what AI is doing is it's actually still only a very intelligent word guesser, and historically, language prediction, language models would look at the previous word or the previous two words to figure out the next word. So 1 or 2 words, 3 words if you're lucky, and so the difference here is we're looking at thousands of words, tens of thousands of words, hundreds of thousands of words. I think the latest Gemini is looking at 1 million words. They call that a context window, 1 million word window. And this is why sometimes I don't really like it when they say it. AI scientists, we actually don't know how it works. So sometimes they say that. We actually exactly know how it works. We can just print out all the parameters, all the weights of the system. but you'll find out that I think the latest GPT-5 is 4 trillion numbers. And Gil, it's not my fault your brain can't handle 4 trillion numbers.
It's my fault because I'm not smart enough.
We can print out the 4 trillion numbers, but the human brain can't look at 4 trillion. We can print them out and work backwards on what it is. And so the quote unquote understanding, and this is where some people think, well, maybe because it looks like it's understanding, is actually language is the abstraction layer for intelligence. It's like a layer. And so one view will say that, no, it's not really understanding at all. It's just predicting the next word, next 2 words, next 10 words. And even people in the field are shocked at how well it works. And so that's why sometimes they say, oh, we actually don't know why it works. Now, if you ask people in the field in computer science 2-3 years ago, when are you going to get to this level? They would have said 50 years from now. And now we've got it right now. And that's why sometimes you're seeing people who get what's called artificial generalized intelligence, which is basically intelligence like we're talking now, bantering, that level in the next 5 years. Now, I think you're going to get more sophisticated, better causation, correlation analysis, better ideas. I think what people are doing, many of my portfolio companies, they're using AI as a collaborator. So I've got this idea, what do you think? And it'll come back and it sparks and you come back and you have this back and forth. And you might think it's thinking, but it's actually just trained on the entire internet and happens to be able to give you interesting sentence. And that works. And that's why maybe language is a layer of intelligence. Now, the thing is, language doesn't give you, there's something called, really it's the IQ bit, the intelligence bit. Interesting enough, there's the emotion part. You say, well, be intelligent, but it's not going to be emotion. It's not going to be empathic. But there are papers coming out that saying the AI is more empathic than doctors are. And sometimes they say the hybrid is the best, but sometimes they say it's even better than when you have a hybrid, humans and machines. It's actually more empathic. But then you've got the other levels of intelligence. It's like we call it the flow. So maybe you're intelligent and you're empathic, but do you have any ambition? Do you actually have any ambition? Does a machine have ambition? Right now, it doesn't have any ambition, which is what humans will keep working on things, banging our head against the wall until it works. That's what humans are great at. Well, stamina, just keep going against all odds. And then you've got, you've got maybe it's intelligence, empathic. Maybe it can get ambition, programming ambition. But you can't get, then maybe, is it compassionate? Right. So imagine you've got a person who's intelligent, empathic, ambitious, but selfish. Right. That's not the nice person to be around with. It's not part of a team player that you want to have. You want to have all of these functions to be able to, these are the multiple levels of ambition. I think we're going to take a long, long time to get those. But you can figure out how to program it. Again, it might be a systems dynamics loop. How would you program guilt into a machine? I mean, it's something that's positive happening, but also something negative happening at the same time. Yeah. We all have feelings of guilt sometimes. And how does that work out mathematically? People aren't even really asking those questions yet in mathematics.
I know that some of those AI companies have a specific people from the psychology domain actually to come and basically be sure that when you ask a question that is not politically correct, like someone, they gave an example of someone asking to develop a atomic bomb, for example. The AI shouldn't answer. So I think that we are adding it on top of the layer. It's not part of the layer. It's a barrier on top of the layer, not to allow AI to do something crazy. And what you are saying, how can we involve it into that the AI will know, hey, or someone that want to, I've seen a video about people that are trying to commit suicide and going to the AI and asking him, what should I do? And he telling them, hey, how to make the rope and how to develop it. And we don't want them to do that. Don't help them to do something crazy. So now it's a layer of human addition that heading it, but it's not a cohesive part of the AI. That's fair to say?
Well, yes. I mean, I call these guardrails that many companies are putting in. My prediction is those will go away, just like the regular internet. You can go on the internet and find anything. because what will happen is, okay, somebody will put guardrails on, some other company or country will not. And people just start using the ones that are open. And so I think you can try as hard as you like. It's my personal view. I mean, a lot of countries and states in the US are trying to quote unquote regulate. Maybe you could have, I mean, what I could think of is kind of like a United Nations type of thing where we agree on doing this and not doing that. But you see this even in nuclear weapons. People don't believe the countries and what they're doing. But maybe AI is at the same level. And when people stop believing that the countries are not developing nuclear weapons, they end up sending monitoring companies and monitoring groups and even invading those countries. And sometimes the countries are telling the truth, but they still get invaded. So it gets to such a high level, people become extra careful on what they do and don't do in that level. So that's the only thing I think it's got to be at that level, the sort of a worldwide. It can't be done at a country level, can't be done at a state level. It has to be done on a worldwide level. That's going to take some time.
That's a problem because the world doesn't agree on anything. So how can we do something in the world level if we don't agree in anything? So I want to, first, it's a great discussion. I really like how you describe AI and what it's doing. I think that our listener will appreciate that. Can you provide a couple of concrete examples of how are we today implying AI tools to health, longevity, and the other domain that are actually related to this podcast? What are we doing today? What is exciting today that our audience should be aware of?
Yes, so I think what hasn't been done quite yet, and I know Insight Track is trying to do some of that, is how do you get all the data in one place? And we all go, I've got my app, I've got a Whoop, I've got an Apple Watch. The Whoop doesn't give as much data out, so you can't really download the data very easily from even on the Apple Watch. You can't really you can download it, but you can't access it from another application unless the application is on the phone. There's all kinds of engineering sort of blockers for you to take the data on your Apple Watch and combine it with your genome sequence and combine it with something your MyFitnessPal that you've been diet, what you've been eating today. And that's one of the things that's still all in silos. And you've got a couple of approaches. You've got some companies saying, take this blood test, take all these, we'll get quite a lot of metrics. And then they've got another set of companies saying, look, you don't need any of those metrics. You just need to measure this. Like heart rate variability, for example. It might be just measure that, and that's a good proxy for everything. You don't have to look at these 80 things. Then you've got things that people are just doing. It's that difficult to measure. I mean, the wearables are, they're measuring how much you're walking and you're running, and but they're not usually measuring what we call it exposometer. What's the air quality like? That's going to start. Some of these things are going to start being merging into the wearables. They're going to start merging. You've seen blood pressure starting to pop up. You can measure blood pressure. That used to be a separate instrument that you have to, where as a result, it wouldn't be continuous. It wouldn't be continuously happening. It'd be once a week or once a day. Some people need to measure blood pressure. Most of us don't. And so just on the occasion when you go to your doctor, they measure it. Clearly sleep quality is measured, but often the blood pressure, the biggest chance of stroke is when you sleep. And if you could measure your blood pressure, then it might give you be able to wake you up before to reduce your blood pressure and the like. So what I'm seeing is, one thing I'm working on is an ageosphere, where you can get data from different places and just put it up, and then you need to use AI to interpret that. So even if it's from the same place, they'll change the format. Your electronic health record in your doctor. Next year the format's changed, right? When I say the format, they may be measuring it in different units, or they may be putting the data in a different column. It could be as simple as data's in a different column. And how does it adjust it? AI can handle those things quite well. It can notice that it's changed. And if you can put them all in one place, then maybe you can use AI to look at all of the data, combine it with everything has been trained on the internet and say, well, okay, no, in my own case, for example, it says that, because I have a full body MRI scan, and how do you get that? Those are huge files. It says, oh, you have some bone problems. And it says, the reason is because your MRI scan shows you got some spinal stenosis where the bones are grinding on each other. But I have no symptoms. I have no problems, right? So it says, your MRI says this, it says you've got bone problems, but your DEXA scan says you're in the 99th percentile of your bone density, says you don't have that problem. And then maybe you look at other metrics to say, well, actually, you're in no worry of osteoporosis because for whatever reason, your nerve structure in your spinal cord isn't actually telling you that you've got, then you can manage your everyday life as a normal person. I'm lucky enough to have that. So if you can actually, I think data is king. We say that in AI all the time. You've got the big data, which is the entire internet, which AIs are training on. But then you've got the really small data, which is us. And it's small data, it's not that small, but it's fragmented. It's collected from different places. And what we need to do is be able to really combine the two. And so then you've got the best of both worlds. As we all know, in supplements, for example, I built a little supplement optimizer. It didn't take me very long to do. You can use something called ChatGPT Builder to do it. It says, well, okay, here's my supplements that I take. Should I take them all at the same time? And it comes out, well, actually, no. It says zinc and magnesium. You shouldn't take them all at the same time because they compete for absorption. What you should do is have a 2-hour separation between taking zinc and magnesium. Notwithstanding that, I was in the airport shop the other day, and you could buy a smoothie with zinc and magnesium combined.
You should let them know that it's not the right.
Exactly. Well, you wouldn't know that. I wouldn't even know. I didn't know that until you programmatically sort of asked the question, right? Here's your state. Here's your vitamin D. Here's your a lot of things that people all have their favorites.
And then there are some people that are consuming hundreds of supplements a day. So for them, most of it is offset each other because of the interaction that you discussed before, and they don't even know about that, and they're wasting a lot of money in the good case, but they might make more harm than value in the worst case. So that's a very good point. So I like what you said. So basically, what you are saying that AI allow us basically to build in a way a data set for ourselves and also arrange it in the right way, that we can basically have all the information about us in a way. Some people call it the digital twin. So you can build a sort of a digital twin of yourself. I don't know if you like this term or not, but some people like it. And then you can run it against all the internet, as you said, or against a lot of people, and try to find some example of what can we extract from that data that you haven't knew before, or you knew before, but now we can reinforce and let you know, yes, you have this problem, or you don't have the problem, like what you said about your bone mineral density. That's a fair simplification of what you said.
I think what you can do. I mean, basically, you can now do the programming across all of this data. And when I think about digital twin, I actually think of something else. Actually, a bigger, more accurate problem that we want to do. Actually, I want to make a digital twin of you, Gil. Right.
Okay.
So basically the entire biology, your entire your hormones, the chemistry, every chemical reaction that goes in you. Right. Now, if I can make that, I can test a treatment on your twin instead of you personally first, and see what's going to happen. I think people would say that's impossible today. You'll never get there. Though you can get to these more simpler versions, as you say. Then maybe you can just look at your 50 blood metrics or skin quality. These are basic things. The ageosphere, that's a really 0.01 sort of implementation. But we should play it forward. Maybe it's 100 years from now. Maybe it's 10 years from now, where we actually can model every single chemical reaction that's going into a person's body, every single thought that they can go think of in their brain, but every single electrical reaction in their brain and what happens to them. What happens when we all know that some people react differently to different things, and that's what makes the human race incredible. No two people are the same. They think differently, they work differently, and that gives us variety and fault tolerance for evolution of our species. Right? We've got 7 billion individuals. Each person is different, and you never know where the brilliant idea is going to come from. Could come from anywhere, and to improve society. So I think, can we actually get a digital twin of each other where we actually say, I'm going to do this, and it might be something innocuous. It might not be even a drug or a supplement. I just say, I'm going to ask Gil this question. Is he going to be angry if I ask him this question, or is he going to be happy? We're going to ask his guy to try it ahead of time before
training before the interview.
Yes, exactly. Then you wouldn't even need to do the interview. Maybe you got the edge.
At the end, the AI will do a better interview. No, I think that it's fascinating, and what you are saying makes a lot of sense for me. And in a way, it's a North Star. So definitely, we cannot do it today because, as you discussed before, we don't know enough about some organ in our body, especially about the brain. So it's very hard to know how our brain is working today yet. But in 5 or 10 years, we'll know. So we'll have all of that.
Well,
Sounds like you disagree with me.
No, well, we have the accelerator. You're going to have it could be 5, 10 years. Most people would say 50 years, but you have the acceleration. Before we didn't have the tool.
Yeah.
Actually analyze the liver to such depth that we could now analyze it. Some of it is dependent on the AI system, the programming, the collecting data. Some of it is actually the data itself. They go hand in hand. If we don't have the data, then the AI can't learn on it, can't learn statistics on the data. And of course, it makes mistakes. Usually people critique these systems that they hallucinate, they make mistakes. But guess what? Humans make mistakes too, right? So they give wrong answers as well. I guess the difference now in this early stage, quote unquote, early stage because I don't think it is very early, the AI is making such ridiculously obvious mistakes.
Yeah.
Humans can say, or even an 8-year-old can know it's a mistake. That's why we say it's no good. But it's learning. And I've seen the number of hallucinations drop. And companies have an incentive to minimize hallucinations because otherwise people don't use them.
Yeah, and we met a couple of weeks ago at the Buck Institute in Northern California. And after that, I went to San Francisco and used the autonomic ride-sharing car. And I told it to my family member, and they said, "Are you crazy? You took a big risk." And I said, "No, I haven't, because I've seen hundreds of those running in the street, and they're running for, I don't know, a few years. So the risk is pretty low." And I think that it's the same there. Today, there are some people that will come say, "I won't go on those autonomic ride-hailing because I perceive that the risk is high." But actually, we know that the risk is not higher than the riding on an Uber with a normal driver. It's the same in a way with AI, and it will become better and better. So, but my question for you, even that we know all of that and sounds like we agree, in your opinion, what is the biggest limitation and risk in applying AI, especially for human health and longevity today? Because think about it. If I make a mistake, I'm asking AI about my publication, and then he's saying he delete one of my publication or heading another one. That's not the end of the world. But if I'm asking AI as a clinician and asking you, okay, I have this situation, and you're telling me, take this drug or this supplement even, and then that's toxic to me, that's a big problem. So what do you see? What is the bigger risk today with AI, especially for health?
Well, people are saying, unlike other, well, actually cars can kill you. So I think that's what people, but I think that's a good example. I think Waymo's, the self-driving cars, are maybe safer than Uber drivers. They're slower.
I assume so, yeah?
I think they're slower. Though.
They are slower, yeah.
And so people say, well, with medicine, when you're trying to take care of people, you don't want much riskier because it could kill people. But lots of things can kill people, and you could argue people not having access to a doctor, certainly in the US, medical insurance is so expensive. Some people go without, and in some countries there's no access to a doctor. And I think the interaction with doctors is going to change. And it's kind of already changed. I think 30 years ago when I went to my doctor, I'd go on a WebMD and print out all these things. And she said, "Oh, don't believe anything you read on the internet." But now she says, "Ronjon, what do you think it is?" Because she knows I've spent 2 hours researching it, and we have a 10 minutes.
Yeah, exactly.
So I'm actually her research assistant, and her research assistant, she hasn't got time to spend 2 hours. Obviously, I'm a very inefficient researcher because she's seen 20,000 patients and I haven't. But between the two of us, it's going to be more of a discussion. I think that's what medicine's going to be. It's going to be more of a discussion. And one part of the discussion is the AI told me this, and the doctor said, "Oh no, it doesn't. It's telling you this because it doesn't know that you don't smoke," et cetera, et cetera, et cetera.
So in a way, instead of Ronjon come to your clinician and telling her that and do the research, AI can do that for her and come and say, okay, that's all the information that we found about him. This is, you can go left, right, or straight, and those are the argument, and then discuss it with him. That can be so it's still a decision making assist. It's not making the final decision, but helping the clinician to be more efficient. That's how you see it?
I think that's what we hope. But you can already see, if I'm a physician, what you mean? I've got to read all these notes before I even see the person. What I've got to enter the interactions. I've got to take account of all these false positives that are popping up. You can call them false positives as the mathematical, or hallucinations, which is the wordy version. I don't know, until it gets better, it's not going to be useful to me. But I think it's useful for patients already. They come in educated. And say, what about this? What about that? And so it's going to be a more sensible conversation for that. And eventually it will be a bit like more interactive in more of a consultation rather than
So it's interesting. You are saying that as of today, it's more a tool for a patient because they have more time and they care about their body the most. Like what you said, you will spend 2 hours on yourself. I can spend 20 hours on myself. We love ourselves. But the clinician have, like, as you said, 20,000 of us, so they don't have time. The AI will be good enough to come to the clinician and say, hey, that's what you should do. And I have 99.9% confidence that that's what you should do. Then it will be good enough for the clinician to come and say, yeah, I follow it or not. But today it's not good enough or not focused enough to do that. That's what is.
I think that, I mean, I've seen this on the drug discovery area, that scientists who work for drug discovery companies or even tech companies, they're using AI as a collaborator. They're asking it, what do you think? What do you think? And how do you do this? And it comes back, do you realize there's a library that does this for you? You're going to write it yourself, and that'll take you months. And if you run it naively, it'll take you 8 months of computing time. But guess what? I found a library on the internet that can let you do the whole thing in a week. You wouldn't. So it's more of a collaborator. It's like a teacher, right? It's something when you went to a teacher or more senior programmer and who just knows the other. They know there's a library out there, but you don't. And often, because things are becoming interdisciplinary, you can actually you things in your field, but as you need to use the tools of another field to help you make your product. And your normal ways, you hire someone in that area. A, that takes time. B, you've got a communication gap. And 3, it costs. I'm seeing time in many of my companies where they're just jumping onto one of the AI systems and interacting with the AI system. And quite often they'll say, oh, you need to use this library. And it's a bit like engineering. Engineers, we abstract things. This is where AI is. It is now abstractable. People who actually don't know how the AI works, the average person, computer scientists, even they may not know, because they're software engineers and they haven't taken a machine learning course. They know how to use it, but they don't know why it works. And then there's a smaller group who've actually learned the mathematics of why it works and how it works. It's a bit like a car. We all know how to drive a car. Probably 60% know how it works, right? And even the 60% who know how it works, we know how it works, but we don't know how to fix it. We don't know how there's even Ford probably doesn't know how the steering wheel, they just buy the steering wheel from somebody, right? And they expect that supplier to know how it works. And they put other put checks to make sure the supplier has produced it correctly. And that's what we're going to do. The average person is going to do that too. They're going to ask AI system. They're going to follow up with extra questions. And, well, did you check this? Did you check that? Did you account for that? And so you're seeing the manufacturing mentality moving to a digital mentality as well, instead of building things from scratch.
Yeah, that's excellent. And we had a great discussion about AI. And I would like to switch gear a bit to another activity that you are doing, and that's the R42 Group. And there you have a few companies related to longevity and AI. Can you pick one of them and describe what the company is doing, what is the thesis behind it, and how do you use AI, and what is the expected outcome from that company?
Right, let's pick one or two. Let's pick Agemica, because it sounds so outlandish. So what Agemica is trying to do is make a vaccine. A vaccine for what? A vaccine for aging. What does that mean? A vaccine.
Yeah, what does it mean?
Does that stop aging? Does that reverse aging? And this is the thing we start. First of all, I'm not sure if you know where R42 comes from, but R is Ronjon. It's a bit narcissistic, I know, but and 42 is after the Hitchhiker's Guide to the Galaxy, which is a satirical book. And the characters are looking for the answer to life, universe, and everything. They finally find out the answer, and the answer is 42. The only problem is they don't know what the question is. And this is quite important. So a lot of my portfolio companies, let's ask a different question. Normal biotech is, let's cure pancreatic cancer. This is a different question. How do we cure all the diseases all at the same time? Sounds outlandish. And but if you just ask the question, and this is what I asked Dr. Yasserman in London, how would we do it? Let's start from first principles. And for age-related diseases, what are they? The age-related diseases, we call them the hallmarks of aging, that are affected as we age. Some of them are obvious. Stem cell exhaustion. It seems like it's harder to get smooth skin as we get older. The telomeres, the ends of our chromosomes, they get shorter and shorter and shorter. Some of these are correlations rather than causation. We're not quite sure. Mitochondria, they sort of lose their integrity, and the battery packs of our cells, and because we don't have batteries, our cells don't work as well. So we sort of started thinking first principles, what is aging and what is illness? And they call this the central dogma theory in DNA. So we all have DNA. And what's amazing is the same molecule in every cell. This is your stomach cell, your skin cell. It's exactly the same cell, the same molecule, but it's expressed differently in each cell. So DNA results in RNA, and it creates proteins, and then the proteins tell our cells what to do. And so if our cells are working correctly, it means their proteins have essentially programmed our cells correctly. Now, what happens when we age is those proteins go awry, they go wrong. And normally it's fine, when you're younger, and sort of teenage years and up, you're younger, your immune system, as soon as they go wrong, the immune system just clears them out. So you don't get cancer very often at 16 years old. Unfortunately, there are a few children who do. And of course, very young children who don't have an immune system built up yet, they get ill. But once you've built up your immune system, then your immune system looks after you. It just clears any bad cells. It just clears. Now, as you age, and when there's something called the thymus just here, which creates your immune system, and then it creates it, from you're born. It gets more dense, and it creates the immune system. And then after about 16 years old, it starts to shrink, and which is fine because you've already got your immune system now, so you don't need it. But when you're 80, you kind of want it back again. So you can either rebuild that or try and find other ways to save your proteins, conserve your proteins, so they don't go wrong. So the cells that have bad proteins, because what happens when they go wrong, they get what's called senescent. The cells become senescent, they become old, and they secrete stuff. And this stuff makes the other cells around them also become old. So the idea is try and nip it in the bud and train your immune system to actually clear those cells at the beginning, as soon as they go awry. Now, how do you do that? So one, we've got the protein. We know what the proteins are, but we can look at proteins from every single animal, every single plant. And the idea, if we trained it on the protein, the problem is it might harm our good cells too. So what do? We train it on parts of the protein. We call them peptides. And we choose peptides, these parts of the protein, that only cover the bad proteins and do not overlap with any of our good proteins in the good cells. And you can now do that computationally. And now these databases. It takes a bit of time. And so we found a set of peptides that can essentially train the immune system to clear out bad cells as soon as they appear. And so that's the idea behind that. And again, doing it step by step. We're starting with cancer cells. Cancer is a good model because you fix one cancer, it's too late. It's gone metastasized to some other organ. So you really have to look at groups of diseases at the same time. And that's basically what we're doing, groups of diseases. And so we think we can do that right now, about 30 cancers, but we were trying to do every disease. It's kind of a moonshot problem. And using the dynamics of entrepreneurship, biology, AI, it's a very tough AI problem to find out the exact match. But there's work that's been done hitherto by other people that have figured out how to make vaccines that are safe, that don't actually overlap with that don't create an immune system that creates autoimmunity, right? In other words, your immune system goes after yourself, which you don't want. So that's a moonshot problem. When I say to people, what you're working on, they say a vaccine. Vaccine for what? Vaccine for aging. And so, well, can I have that? When's the trial started? And you have lots and lots of already. You may have those. Well, how are you going to test it? You won't know for another 30 years whether it's working or not. There are all kinds of ideas of trying to. And then how do you test? How do you get it through trials? Are you going to test every disease all at once? That'd be very expensive.
Yeah, it's a good question. Yeah.
So we've got lots of ideas on how to solve those problems. And so that's a good aging one. Another one I like is more of an investment. That's one I'm actually working on myself. It's olfactive biosolutions, which is a GLP-1 agonist, but which many your audience may have heard of. GLP-1 is part of the way Ozempic or Mounjaro. There's a set of weight loss drugs work, and people think actually the first staging vaccine may be GLP-1 actually, because it's turning out it's not just the weight loss, it actually helps in lots of other diseases as well. And what people don't really know is it the weight loss part or is it actually the GLP-1 mechanism? I think there is some evidence actually in the mechanism itself. So even if you're healthy, I think right now I read in an article that him and hers, which is the consumer prescription version of GLP-1, they make it easy to get a prescription. They're now giving it microdosing to people who are not overweight. They're not overweight. They're not obese, and they're encouraging people to take microdoses of GLP-1 to be prophylactic, in other words, be prepared ahead of time. And so that's what. Olfactive Biosolutions does is their product's called Pivot, get Pivot, get pivit.com. and it's a food, so you actually don't need a prescription, and it's a pill, so you don't have an injection either. And it certainly, I've been trying it. It seems to work, and the founders lost 50 pounds. And so sometimes I go on these panels, and maybe I should ask you, Gil. I go on these panels, on these talks, and say, well, let's just quit talking. Let's go and have a race. And then whoever wins the race, let's listen to her. It's what's your mile time? You should ask your guest. By the way, what is your mile time? And then, the better the number, the more we should listen to them.
Maybe what is your biological age? But the example of the GLP-1 company. So how it's different than Lilly now coming with basically oral GLP-1? What is the difference between?
The idea is made out of food, what they call GRAS ingredients, generally recognized.
Oh, so it's basically natural food that you basically.
Yeah, so you don't need a prescription. There's no prescription. You just buy it over the counter.
Okay.
And then the other theory is because it's made from food, there's going to be less side effects. I think it is less potent, but it means you have to sort of take it every day, whereas the injections are like once a week or so, once every 2 weeks.
Yes.
And so this you have to take every day. So it's, but I think for people who are not particularly overweight, then it's good for prophylactic purposes to do ahead of time. And if you are overweight, but you don't like injections, I don't like injections. I can just cope with a blood draw, but I don't really like injections. I'm always a bit concerned. And if you do the injection yourself, there's one thing getting the injection, but in doing the injection yourself is even worse. But it's, I guess people get over it. I'm told people get over it. So that's a big difference.
It's all about, in my opinion, it's all about the balance between value versus cost. So if you are obese and you will lose 50 pounds, the injection makes sense. But as you say, the customer of him and her, if he need to inject just to feel a bit better, I think that then maybe it's better to have what your company are making, basically a natural feel that you take it, because to inject every week, it's a pain. Definitely, it's a pain. The value might be much less than the obese person.
Yeah, so there's this middle market of people, they're maybe a little overweight, or maybe I'm in that category, a little overweight, but not quote unquote obese, pre-obese. Right?
Overweight, let's say, yeah.
And there's loads of people, probably half the population is in the US. I don't know about you, Gil.
Even more, yeah.
You notice instantly. You go to another country, as soon as you land, you see all the immigration officers, and they look all so thin. Any other country except the US, and everyone who come to the US, everyone's a little bit overweight.
Yeah, and I think that if we are thinking about that, and it's getting me back to the discussion that you started about smoking and alcohol, another big problem that we have in the US is all the fast food that we have, that is the ultra processed food, let's say, that we are consuming. And your prediction about alcohol, I agree with you that it might be something bad, like a cigarette in, 10 or 20 years. Also, the ultra processed food will be like that, especially all the fast food. So I think that we will get there, and that's maybe one of the reasons, because in a way, we created the fast food in order to make money. This making money make all of us fat, and now we came with a solution, which is GLP-1 to decrease it. So basically, we came with a solution to fix the problem that we created in a way.
Well, there is a conspiracy theory that is industrial food complex, industrial pharma food complex. But I think I've been thinking about the processed food. Why does processed food not good for us? Because chemically it's the same. Processed food, we lose the fiber, I think. Certainly fast food, it has been a sort of commoditizer that you can get cheap food quickly and has nutrition despite the debate. So I'm not completely snobbish on fast food, but the problem is it does remove lots of good ingredients that natural foods have.
Correct, and it's also had some ingredient that you don't want. A lot of sugar, a lot of salt, a lot of fat. And it's also addictive. So in a way, they found the formula that you go and eat in McDonald's, you want another on Big Mac. One is not enough, and it will make you come tomorrow. So the addiction of that, I think that the mix of all of that, definitely if you go to McDonald's and eat the salad without dressing, you're good. The salad is the salad. But most of us are not going there and eat the salad. That's the problem, in my opinion.
I get the burger. I actually eat salad without dressing. I never put dressing on. But in McDonald's, I'm not buying the salad. I'm buying the hamburger.
Exactly. That's the. So Ronjon, that was a great discussion, and I have a few. I call it a rapid fire round of questions before we finish. So the first one is one AI or a system concept you use regularly in your life.
I use lovable.dev to build apps. Those of you who don't know what that is, it's you just type in English and it'll build apps for you.
Amazing. Thank you for that.
Yeah.
Another one is one daily habit that best supports your health plan.
Running.
Okay. Can you elaborate?
It's the most time efficient. If you can run, not sometimes people get, and one of the problems of running is you get injured, but even if you're overweight, it's literally the most time efficient exercise you can possibly do. 10 minutes of running is better than 90 minutes of walking, because you get your heart rate higher, which you will never get walking. So running is so I do about 25 miles a week, give or take. And
nice. That's very nice.
And so I've run a few marathons, but I never used to. My first 30 years, I did nothing. And last 10 years got more organized. And it's a time thing. It's more, I could do other exercises, but running, makes you a bit stiff. So I combine it with yoga. I don't do enough yoga, really, but running makes you a bit stiff as well. But overall, the heart is the number one killer, heart disease. So running will reduce your resting heart rate, increase your HRV, protect you from sarcopenia, at least in the biggest muscles of your body, which are in the legs. So that's what I would do. Try and do some running, even if it's just a few minutes.
Excellent. And what is the longevity intervention you think is overhyped?
Overhyped. Let's see. I've tried pretty much every supplement, and some of them might work. I think rapamycin, metformin, probably. I've not tried those two. Maybe I'd consider it when I'm 80. I think if you can do the exercise, do the diet, you'll probably be at the upper levels of health where you won't need metformin and you won't need rapamycin. And so I think some people do ask, we've got a supplement. Some people ask me, well, what food can you get vitamin C in? I say oranges, but you need to eat 20 oranges.
Yeah.
Do you really need to eat 20? Or maybe one orange gives you enough value because it just goes straight through you, but you've got slow release vitamin C. I take alpha.
And the fiber. We spoke about fiber. Every fruit has the fiber.
It's fiber. So, Swiss birch, muesli.
Phytonutrient that we don't really understand, but there are a lot of.
Metamucil, if you don't want to take it, some people just, again, it's a time, take it as a pill. You can go to Walgreens and buy these fiber pills. Yeah. They're pretty much, I think they're not as good as real fiber, but it turns out there's different types of fiber, and different types of people are affected by the different types of fiber.
Absolutely.
And then I think, give me more questions, Gil. What more?
Yeah. How do you personally recharge or maintain resilience?
Yeah, resilience. Well, I think I take the recommendations of the last few people who got to the oldest level. People, Maria from Spain, she said, avoid toxic people. I think be sociable. I think that's the other. They call these the lifestyles medicine: diet, exercise, sleep, sleep and social. I need to work on my sleep, but social is important. Go and meet people, go and talk to things. Take opportunities like this. Someone asks you for a conversation, and it's a new person. You get energy from the other person. There's a book called Digital Exhaustion, which says people are texting and WhatsApping each other all the time. you just exhaust yourself. Just get on the phone, and not only do you get the information transfer, but you get the positive energy of the other person as well.
Yeah, and again, even more than that, get on a video call and then you will see the person, and even more than that, go and meet with him and go for a walk. Then you get So I think that the digitization remove a lot of the real world, and we need to go back and to the real world. It's not enough to,
I think it's harming us in a way. It probably is harming us. Like eventually, maybe 30, that'll be the new smoking. So, well, why are we doing a video call? Well, let's meet and have a
exactly. Last question that I have: if our listener remember just one idea from your work, what should it be?
Right. I think big. Right. Don't worry about naysayers. This is maybe people on the more entrepreneur side. Aging vaccine. 1983, I was talking about a machine that you talk to, you'll just type everything out. At the time, people thought it was ridiculous, right? You wait 18, 20 years, and we are going to live longer. That's going to be one thing. The other thing is, if you're under 40, you will live forever. You will live forever. So if you're going to live forever, how are you going to change your life? One thing, maybe you don't need to rush everything anymore. So that extra, you want to travel for a year, go ahead, travel. You want to do that extra degree in that other topic, go ahead, do it. Right, and it will it might lend itself to more interdisciplinary work, I think, which seems to be the other dimension of society. Everything's interdisciplinary now. There's not one subject.
Yeah, that's a bold statement that people below 40 will live forever, but I will buy it. So I finger crossed that it will happen. And as an entrepreneur, as you said, you need to be bold, because if you won't be bold, you won't change the world. So I applaud you for that. So thank you so much for joining us and sharing how artificial intelligence, system thinking, and biology are converting to reshape the future of health and longevity. For listeners who want to learn more, explore his work through the R42 Group and his research at Stanford. For our listeners, if you are enjoy today's episode of Longevity by Design, please like and follow the podcast on the Apple Podcasts, Spotify, and YouTube. And leaving a rating or review help others discover this conversation about science, health, and longevity. Thanks again, and looking forward to interviewing other experts in the field in the future. Thanks again, Ronjon.
Thank you for having me. It's been a great pleasure.
Thanks for listening to Longevity by Design. Please subscribe to this podcast on Apple, Spotify, or YouTube. Longevity by Design is powered by Inside Tracker, a personalized health optimization platform that helps people improve their lives by improving their bodies from the inside out, using personalized, science-backed recommendations for nutrition, supplements, and lifestyle changes. To learn more, visit insidetracker.com/podcast.